So we thought it was going to be relevant to have Can sharing with us his knowledge, because clearly light and temperature have played a major role since other sources of deficit, water or nitrogen, were not on the forefront in 2016. So how can we make progresses? How can we learn more about the time profile of those color accumulation? Last year at the Vintage Report, we were discussing this decoupling between sugar and color accumulation, which is mainly believed to be affected by temperature threshold going under or above 35 Celsius. And it seems that the decoupling occurs around that sweet spot. So, but each situation being different, we thought it was going to be interesting to share with you some results we obtained this year by looking at the time profiles of color accumulation regardless of sugar, and also looking at how the side of the row, is the cluster facing the morning sun or is the cluster facing the afternoon sun, was affecting the color accumulation pattern. And in order to do that on the same cluster, we use a non-destructive technique, which is again based on fluorescence, but this time instead of focusing on flavonols and nitrogen and chlorophyll, we purely focus on total anthocyanin. So it's a different machine, but the principle is the same. We excite the skin compounds and we look at how their excitation bounces back, and as it bounces back towards the observer, a fraction of what has bounced back has been actually filtered out, screened off by anthocyanin compounds. And this is the technique we used. So here on the y-axis you are looking at anthocyanin accumulation measured non-destructively and expressed therefore in terms of milligram per square centimeter of skin. So of course you are seeing similar patterns than the ones I was discussing earlier based off Matthews, the Chilean colleagues. But you see that actually the picture is quite interesting, because Can was explaining that in Bakersfield, once you are reached your peak of color around 17 Brix or 18 or 19 Brix, then you have a brutal decline, and sometimes you're back to initial stage that you had at the beginning of veraison. So you see from the veraison on, it's either a constant accumulation followed by a decline, and the steepness of this decline is site dependent, row orientation, misting, shade cloth, etc. But some sites, either because you are modulating the speed at which color accumulates via practices, or maybe also because you have a higher crop load, you see that by the end of September, we have not even reached that plateau. So what I'm trying to convey here is that the peak of color is extremely variable according to the site. We only understand that temperature degrades and negatively affects the trajectory of those accumulations. So therefore, the question that naturally occurred to us was, well, let's keep everything equal, so same vineyard. That way you look at the same ground effect in terms of heating reflection, you look at the same row orientation, you look at the same spacing, you look at the same practices. You only identify and discriminate if the sun facing in the morning or the sun facing aspect in the afternoon changes the thing. And to keep things simple, I was asking myself, well, is it like just identical twins where both sides of the row are looking the same, or are we looking at, it's almost the same, but they are actually more like fraternal twins, and each row side is significantly different from an early stage on. So in order to capture those differences, we came up with those measurement protocols. So on your left side, you are looking at vineyards where the combination of practices and decisions regarding the vineyard layout led you to have fruit maturation on both sides of the row very similar, like identical twins, so to speak. The only differences we could identify is that on the afternoon sun facing, the peak is reached earlier and is lower. Again, those units are obtained by fluorescence, so it's milligram per square centimeter of berry skin. So, but the trajectory is the same. You see, from the very get-go, that's only, we are looking at that level of differences. However, in some other situations where the set of decision is different, Well, we have from the very get-go a lower initial potential of color, and the speed of accumulation mirror the same one you observe on the morning sun facing, but it's systematically 15% below. So here you have almost two very different vineyards. The potential in terms of co-pigmentation will naturally be affected, hence the sensorial properties, the amount of color incorporation into the tannins. So I thought that kind of knowledge will actually have direct consequences in terms of how should I space my vineyard, what row direction should be preferred, should I invest in a shade close system, should I invest in a misting system, should I preventively leave the laterals at the cost of not having enough light penetration early season in order to avoid that drop. So there is no simple answer. I can't tell you fraternal twins are obtained that way or that way, because another element that's key is the topography of the vineyard. The slope steepness and the slope aspect sometimes have a greater say than even your practices. So that's the fifth take-home I wanted to say, that through the analysis, so we had hundreds of profiles, but everywhere the keynote was impacted by light exposure systematically. The shape, the trajectory of accumulation is generally an increase, a leveling off, but you are not bound to observe a decline. You saw that sometimes it keeps increasing and sometimes it stays steady with some benefit on co-pigmentation, one might think. And then cluster facing afternoon sun, the only general trend is that it levels off earlier most of the time and it reaches a lower peak value. So in practice, well, rethink your practice according to the relative impact of temperature versus light, and really start to pay attention at other elements that really may make your practices a little bit not useless, but of a degree of magnitude below in terms of efficacy. Shade close, misting, canopy width, and lateral, that's great to manipulate the microclimate, but what kind of microclimate do you start with? And for that, it's important to acknowledge slope aspect. So aspect is really the deviation from the north-south axis. Here you see a vineyard with a 45-degree aspect. Here you see a vineyard with a 225-degree aspect, southwest versus northeast. But here is what you see in a typical vineyard where the terrain is showing a lot of variability. The color distribution here does not tell you the slope aspect. The color distribution here reflects the percentage of time spent over 35 degrees Celsius. And you see that different situation will drive different temperature regime, therefore different harvest date decision and different way of working the cap. Should you be more aggressive or should you be more soft, depending on how much time you have spent at peak value in terms of total anthocyanin. So those are the kind of reflection that the winemaker can use in order to customize his winemaking decision based on the origins of the fruit. So that's why I thought it was going to be relevant to invite Caroline Merrell from Washington State University, since in a few weeks she will be done with her PhD.